Hello everyone, this is Ranjit, Department of Computer Science and Artificial Intelligence, SR University, Warangal. In this session, I would like to explain classless interdomain routing and variable length subnet mask in the computer networks. So before starting these two topics, first I would like to explain overview of IP addressing. For the detailed explanation of IP addressing, you can refer my previous video on IP addressing. Here, I will explain only the overview of IP addressing before starting these two topics. So IP address means that is an internet protocol address. So every system connected to the internet must have the IP address. So without IP address, the communication among devices over the network is impossible. And these IP addresses are divided into 5 classes: class A, B, C, D, E. And again, each IP address divided into two parts, that is network ID or network address, host ID or host address. Here the IP address divided into 4 bytes or 4 octets, and each octet size is 1 byte. 1 byte equals to 8 binary bits. So let us take class A. In this class A, first byte represents network address, last 3 bytes represents host address. So that means host address means system's address. So in this class A, 8 bits we are using to represent the host address. 8 bytes, 3 bytes. So 3 bytes, each byte is 8 bits, means total 24 bits used for the host address. That means total 2 power 24 host addresses can be generated for one network. So similarly, class B, class C also same. So class D for the multicast address, and this is reserved for the future use. And in the class C, network address first 3 bytes, host address last byte. So last byte means only 8 bits. So 2 power 8 host addresses can be generated for one network in the class C. So let us consider this class C. So here class C has 8 bits for the host address. So 2 power 8, 256, that is 0 to 255 system addresses can be generated by using the class C. So, but assume that we are using only 50 systems. We want only 50 addresses. So 50 addresses means definitely we have to use class C because it is producing lowest number of host addresses compared to the class A and B. Here class C 2 power 8, but class B 2 power 16 and class A 2 power 24. These two are more than this 256. So this is producing lowest number of IP addresses. So we must use that when we want 50 IP addresses. So if we are using 50 IP addresses, then class C produces 256. So then 256 minus 50. So then 206. Means 206 will be wasted. We use only 50 out of 256. So remaining all is going to be wasted. So this is a problem with the classful address. And coming to the subnet mask, actually subnet mask represents which part of the IP address represents network address and which part represents a host address. In this class A, B, C, network address part, host address part are fixed. Those cannot be changed. So, for example, class A has one first byte is the network address, remaining 3 host address. That's why in the subnet mask, so in the subnet mask, first byte 255 will be written. That is the maximum number. Right? In each byte, the maximum number is 0 to 255. So 255 written, remaining 3 bytes zeros. Means in the IP address, first byte represents network address, remaining 3 bytes host address. So similarly, class B, class C also same. So class B first 2 bytes network address, that's why first 2 bytes 255 written. So remaining 2 bytes zeros. So zeros means the last 2 bytes represents host address. So similarly, class C also. So here this subnet mask cannot be changed because Here network part and host part are fixed in these three classes. That is in the classful address. So that's why subnet mask will also be fixed. Okay, that is one thing. And second thing is some number of addresses are going to be wasted. So these are the some issues with the classful address. That's why these days, so classful addresses are not in use. So we are using the solution for this is classless interdomain routing. Means everyone using this classless addressing only instead of the classful address. So for these are the problems, the solution for these problems is a CIDR, classless interdomain routing, and where we can also take variable length subnet mask. Here fixed length subnet mask. So coming to the classless interdomain routing. So this is a method of allocating IP addresses and routing IP packets efficiently compared to the old one. Okay. So compared to the old one means just like I told you the classes, classful addresses are there. By using classful addresses, there are some issues. So to avoid that issues, here classless interdomain routing will be used. And your old classes means only ABC mentioned here because most generally only ABC classes will be used. So D for the multicasting and E for the future use. So that's why generally that is reserved. So that's why generally only ABC first three classes will be used for the general purpose. So while writing this CIDR notation, we use slash notation. The slash notation defines network prefix. So network prefix means this network prefix is a number that represents how many bits from the IP address used for the network address. Because there is no class, if there is a class, we can decide which part is network part, which part is host part. But here no classes, this is classless. So that's why this slash notation is used and that defines network prefix. And this prefix is a number which that decides how many bits from the IP address used for the network address. So let us take an example here. This is one general form of the IP address a.b.c.d/n. Right? So IP address has 4 octets. Those octets I'm representing as ABCD, and each octet separated by the dot. That's why a.b.c.d/n. So n represents network prefix. That means in this IP address, first n bits are used for the network address and remaining are host address. So anyhow, we know that IPv6 size is 32 bits. So 32 minus n. N is number of bits used for the network address. 32 is the maximum length of the IP address. 32 minus n, let us take it as h. This h bits represents number of bits used to represent the host address. In this way, by using this network prefix, we can decide how many bits for the network address, how many bits for the host address. So that can be varied according to our convenience. We can take any number of bits. For example, I want to take only 2 bits for the network address. So then in place of the n, we can write 2. So I can take 3 bits, I can take 4 bits. So likewise, how many bits, how many networks we need according to our requirement, we can change this n value. But in the classful address, that cannot be changed. That is fixed. Either 1 byte or 2 bytes or 3 bytes for the network address. So let us take one example. Here 198.162.10.0/24. So 24 means in this IP address, first 24 binary bits. So we have to represent this in the binary form. So first 24 bits are used to represent the network address and remaining host address. So first 24 bits means first 3 bytes. Okay. So first 3 bytes means this is almost similar to the class C addressing. Okay. So then subnet mask will be first 3 bytes network address. That's why first 3 bytes 255.255.255.0. So let us take another example 198. So /25. /25 means first 25 bits used for the network address, remaining host address. So So first 25 means up to first 24. 8 bits, 8 bits, 8 bits. So this is 24. And next 25 means from the last byte. So 25. So let me represent this. Last byte I am representing in 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So up to 24 bits that is used for the network address. 25th means from the last byte, first byte will be taken here. This will be taken for the network address. Okay. So that's why here let us take 1 I am taking, right? So that could be 0 or 1, whatever it is. So as an example, I am taking it as 1. So 1 means 1, remaining all followed by 0. So 1 followed by the 7 zeros. So this is equals to the 128. You convert this into binary value into decimal, that gives the 128. So that's why here I have written 128. Otherwise, this is 1 bit means you can also take 0. Okay, 1 bit we are taking means that is 0 and 1, both are possible. But in this case, I have taken 1. Okay. So total 25 bits. Here, this is one address. Now coming to the subnet mask, 25 bits means first 3 bytes represents the network address by default. That's why first 3 bytes I have written maximum number, 255, 255 like that. But from the last byte, I am taking only 1 bit to make total count as 25. So from the last byte, I am taking only 1 bit. So that's why this 1 bit is reserved for the network address. So remaining 7 bits host address. Okay. So that's why in this first place you write the maximum value. Maximum value will be 1. Okay, starts from the 0 to 1. Last one is 1. Okay. So if you place 1 here and the remaining all are zeros here, so then its value equals to 128. That's why in the subnet mask 128 written. That is 128. But here this can be 128, otherwise 0. Because here two possibilities are there, 0 and 1. Anything can be written. Okay. So in this way, if we have a look at this, now here if you have a look at this subnet mask, you can find the difference. So that subnet mask is not fixed, right? So here something and here something. Here 24 bits taken, here 25 bits taken. So like that, that can be changed, right? So this is called as variable length subnet mask. So this is possible because of this classless interdomain routing. So where we are taking different addresses. I mean, different number of bits used to represent the network address. So now let us take a simple example how this classless interdomain routing is used and how that is divided among different, let us take some different organizations. So here I displayed here 2 power 0, 2 power 1, 2 power 2 up to 2 power 7. These values and these values some displayed here. These will be useful when we are talking about this. I will tell you that. So now once you go through this question, some internet service provider providing the CIDR based IP address, that is 245.248.128.0/20. Okay. Divided into two parts, and one part first half given to the organization A and 1/4 given to the organization B. So then what is the starting address and ending address of those two organizations? So that we discuss here. So let us say this is one entire network. Entire network addresses, total address pool. So this address pool means this total network address is 245.248.128.0/20. Okay. So now what is the first part? That is divided into two halves. So here this is divided into two parts. So divided into two parts means here this is 20/20 means from this address 20 bytes are used for the network address. So the IP address maximum length is 32. So from this 32, 20 for the network address means 32 minus 20, that is 12. So 12 used for the host address. So 12 used for the host address, 12 bits. So 12 bits means how many maximum number of host address can be generated? 2 power 12. That is 4096. Okay. So 4096 means for this entire network. For this entire network, 4096 systems can be connected. Now we are dividing that into two parts. So two parts means 4096 divided into two parts. That is 2048. 2048 means this side 2048, this side 2048. And this is, let us assume that organization A. And again, this right side quarter given to the B. Now right side you divide that into again two parts. Now this is quarter, this is 1/4, this is half. Okay. So you can also divide this into two parts, but these two parts given to the organization A. So that's why no need to divide that. So now let us consider this part, this quarter is given to the B. Okay. Initially this is total 4096. This 4096 divided into two equal parts, that is 2048. So means this side 2048 systems and remaining side 2048 systems. So this side 2048 and this side 2048. So 2048 means how this is represented in the form of 2 power something. So every time when we are dividing, we should divide, take some bits. So like that should be represented in the 2 power something, maybe 2 power 1 or 2 power 2 or 3, 4, 5, 6 like that. So now this is 2048 systems possible in the organization A, but how many bits used to represent 2 power 48? So that we should convert into 2 power something. So here already I given here 2048 means 2 power 11 is 2048. So that means this side 11 bits are used to represent a host address on this organization A side. Okay. So similarly, organization this total remaining side same 2 power 11. Okay. So this is again this is 2 power 2048 divided into two parts means 2 power 2048 divided into two parts. That is 1024. This is 1024 and this is 1024. So now this is 2 power 2048 represented as 2 power 11 means 11 bits used for in organization A for the host address. Now coming to the B, this is 1024. So 1024 represented as 2 power 10. So that means in this B part, 10 bits used for the host address, 2 power 10. And this part also same, but leave it. Just we are focusing on A and B only. So B and this part both are same. Okay, 1024, 1024. So now we have to determine what is the starting address of this A organization and ending address of A organization. Similarly, starting and ending address of the B organization. Okay. So now coming to organization A, 2048. So 2048 means here look at this 2048 11 bits. 11 bits are used for the host address. So total IP address is 32 bits. 11 bits for the host address. Then 32 minus 11. Okay. So 32 minus 11 means 21. So means 21 bits are used as a network address bits for this organization A. So then we should write this IP address as 245.248/20/21. Okay. So 245.248/128.0.21. So in my previous video also I told you that once this network is given, first address represents network address. That same is going to be the network address for the subnet 1. Subnet 1 means here we are taking this A as a subnet 1. So the whole network address becomes the network address of the subnet 1. So that's why here I have written. So in this case, 21 bits used for the network address means these are 8 bits, 8, 8, 16, and from here 5. Okay. Anyhow, up to here, no problem. But here, 8 bits are there. From the 8 bits, 5 bits are taken for the network address. 5 bits means, look at this. So 2 power 0, 2 power 1 up to 2 power 7. So 5 bits means this is the last 5 bits. Where are the last 5 bits? So these are the last 5 bits. Okay. So these are the last 5. Okay. 2 power 7, 6, 5, and up to 3. And these bits are used for the network address. So this address is 128 given. So that's why 128 means 2 power 7th bit is 128. So that's the first bit I am writing 1, 0, 0, 0, 0. So this is total 5 bits. First one is 1, 128. So remaining are zeros. So remaining how many zeros? 5 over means 3 zeros. So this is first byte is over. This is first byte. So now coming to the last byte, that is initially 0. So all zeros, leave it. Okay. So now starting from here, we are going on generating all addresses. Okay. So for this entire network, address is 128. 128 means first 5 bits. Up to first 5 bits, we should not change this. Only last 3 zeros will be changed in this 128 part. Likewise, when we are going up to the last address means these first 3 places becomes all ones. So all ones means look at the first 3 all ones means to convert this into decimal. So that decimal is 2 power 0, 2 power 1, 2 power 2. So those are 7. Okay. So 7 places this is 128. Okay. So that is 135. So that's why last address is going to be this one 135. 245, 245, 55, this is common. So this part will be changed, that is 135. And last one is starts from the 0. This last byte initially all zeros and last address is going to be all ones. Once it is all ones means that is 255. That's why last byte is 255. Okay. So this is the starting address and this is the ending address of this organization A. So now let us go to the B side. So B side means what is the B side here? 1028 24. 1024 means so look at this 1024 means so 2 power 10 means 10 bits are used for the network address. Sorry, host address. Okay, these many hosts are there. In order to represent those many number of systems, we use 10 bits. So 10 bits means total 32 bits of IP address. From that minus 10, this is host address. So then remaining how many? 22. So 22 for the network address. Okay. So 22 for the network address. Now first address, here this is the last address 135. So automatically next one is going to be the 136. Okay. So next one will be the 136. So for that 136, so what is the address? How many bits we are using? 22. 22 means from this 6, 8, 8, 6, next 6. Okay. So 8 plus 8, 16, 16 plus 6, 22. So because this part, network address bits are 22. Okay. So that's why here 6 bits from here used for the network address, and that should be 136. Sorry, 136. So 136 means what is 135? Here the next address is going to be 136 because here this is 135 is the last address. So next is going to be 136. So 136 means, so there we have to use 22 bits as the network address. That means 8, 8, 16, 16 plus 6, 22. Means from this third byte, we have to take 6. So 6 means, so these bits. So these bits are used for the, so total 6 bits. Up to here, these bits are used for the network address. So remaining 2 for the host. From these 6 bits, so what are the binary value? By adding which numbers we get 136, we have to check. So 136 means you 8 plus 128, this is one type. 136. That means, so first bit is 1, so remaining 3 zeros, and fourth one is 1. Up to here, so these, so how many bits? 1, 2, 3, 1, 2, 3, 4. And this last one is 0. Now these are 6 bits. So these are 8 plus 8, 16. So 16 plus these 6. Now total 22. So 6 bits are over. So remaining only 2 zeros. 2 zeros. So this part is common for the entire B. For this B, from the starting to the ending, this part is common because that represents the network address. Right? So that's why here the starting address is, this is going to be the starting address. Okay. So this 36 is nothing but this one. In the binary form, I represented 36. So this last one is going to be 0. Anyhow, that starts from the 0. Okay. So while writing this first two parts, I am not changing, writing as it is in the decimal. Only when we are taking extra bits, means a few bits from the next byte, that byte I am representing in the binary for the clarity. Okay. So now this is the starting address. Now coming to the ending address. So if you want to go for the ending address, so let me write one. 22 bits we should not change throughout from the starting to the ending of the organization B. So 22 bits we should not change here. Now what is the binary value of this one? These bytes I am not changing, only this byte I am changing because here 88 is 16. So 6 bits taken from this 136. So 6 bits means 1, 0, 0, 0, 3 zeros and 1 0. Up to here network address. So remaining 2 bits can be used for the host address, and dot, this last bit is 0. So all zeros here I am representing in the binary. All zeros means totally 8 zeros. Now this is from here to here, no change. Up to here we should not change anything. Only these last 2 will be changed. So last 2 will be changed means this is as it is written up to here. And this part will be changed. So maximum value is going to be 1 1. And that last part maximum value is going to be all 1. Okay. Now here this is how much binary, sorry, decimal value of this third byte. So this is 136 up to here. And the last 2 are going to be 1 1. 1 1 means you add these 2. Just otherwise you 1 1 convert into the decimal. So 1 1 means 3. 3 means that is 136 plus 3. Now it is going to be 139. Okay. This last one, all ones. So all ones means that is 255. Okay. And this 255, 245 and 248 will be written as it is. This will be the last address of this organization B. Okay. So in this way, while converting, to find out that space, we have to convert that into a binary as far as some network address is concerned, binary, and after that calculate the decimal, then we can write that decimal address. Now I will write, just I will erase and write the decimal address 139.255. Okay. So just erase this. So look at this. So this is the maximum value, maximum address of this last address of this organization B. Okay, so this is the starting address and this is the last address of the organization B, and this is starting address and last address of the organization A. And one more point here, 1024, but out of this here to this is starting address and last address, and starting address is always represents the network address, and its last address always represents the host address, broadcast address. For example, if this address space, in this address we have, just assume that total it represents n addresses, but only n minus 2 used to represent hosts or systems in the network, because first address reserved for the network address, last address reserved for the host address. So in this way, CIDR will be used, and here if you observe, for this 21 bits are used for the network address, for this 22 bits are used for network address, and for this one also 22 bits, right? So based on this, so we can take a number of bits used to network address based on our requirement, and accordingly the subnet mask will also be changed. So that's why this subnet mask can be called as a variable length subnet mask that is generated because of the classless interdomain routing. So using classless interdomain routing, we can reduce wastage of IP addresses. And whenever we are dividing any network into subnetwork, so we should follow this rule, that is 2 power n. In the form of the 2 power n, we divide that network into some subnetworks. Okay, so this is about CIDR and variable and subnet mask. So I think this is informative video. So thank you for watching.